Assalamu alaikum class. Today we will be doing with the numericals of chapter number 3. So let's discuss every numerical in detail. The first numerical is like an object is placed at a distance of 30 centimeter from a concave mirror of focal length 5 centimeter. If the object is 5 centimeter high, find the position and size of the image. In this question, we are given with the object distance, that is 30 centimeter, and the mirror is of course concave mirror, and its focal length is 5 centimeter. So two things are given to us from the mirror equation. One is f is given to us, and the other is p is given to us, and we are supposed to find q. So I hope this is clear. And the second part, if the object is 5 centimeter high, this means that object height is given and we are supposed to find the image height. So there are two entities are unknown to us. Those are image distance and image height. So now let's do it practically over here. So given data, what is given to us? That is very important. So P is given to us, that is 30 centimeter as we discussed it, and F is given to us, that is 5 centimeter, and object height is given to us. Object height means HO, that means 5 centimeter. And what we are supposed to find? We are supposed to find two things. So now I'm writing to find. Means two things we have to find. Number first is like we have to find Q, and number second is we have to find HI. HI means image height. I hope this is clear. So now we are doing for Q. So we will be using the formula. So what will be the appropriate formula for this numerical? It is, we know that is 1 over f is equal to 1 over p plus 1 over q. You know better, this is the mirror equation. So we will be using this equation to find the unknown value, that is q. So next step is like we will be putting the values. So when we insert the values, like 1 over f is given to us, that is 5, and p is given to us, that is 30, plus q is not given to us. We are supposed to find q, so I am writing it as it is. So next step is like 1 over 30 we will take 1 over 30 to left hand side, so it becomes minus, and we are supposed to find q. I am writing it as it is. I hope this is clear. So now we will be taking LCM. So when we take LCM, what will happen? So 30 will be LCM. So we multiply 6 over here and we multiply 6 over here. So it becomes 6 minus 1 is equal to 1 over q. When we subtract 1 from 6, it becomes 5 over 30 is equal to 1 over q. So after cross multiplication, so what will happen? 5q over 30. I hope this is clear. And rest of the part I am solving it over here. So what will happen when we, okay, now rest of the part I am solving it over here for you. 5q is equal to 30. I hope it is visible to you, for you. And now we are supposed to find the q. So what will happen? Since 5 was multiplying over here, when we take 5 to the right hand side, so it will divide. So in this way we got the answer. Q is how much? 6 times 5 6 times is 30. So we got the answer, that is Q is equal to 6 centimeter. So now we are supposed to find the second entity, that is HI. So we know that the formula is like, what is the formula? HO over HI is equal to P over Q. So now what we have to do is we have to put the values, putting the values. HO is given to us, that is how much, 5, and HI we are supposed to find the value of HI, and P is given to us, that is 30, and Q, the value of Q, we got the answer like 6. So we plug in the values. After cross multiplication we get what, 5 times 60 is 30, and 30 times HI, and then 30 over 30, so it becomes HI, so it becomes 1. After 30 and 30 will cancel each other, so the value of HI is 1 centimeter. So this is the answer. So I hope this is clear. So in this numerical we were supposed to find the values of Q and HI. HI means image height and Q means image distance. I hope this numerical is clear to you. Now let's move on to the second numerical. The second numerical is like, if an object is placed at a distance of 10 centimeter from a spherical mirror and its virtual image is formed at a distance of 5 centimeter from the mirror, find the focal length and nature of the mirror. So in this numerical we are given with an object is placed at a distance of 10 centimeter. This means object is placed at some distance of 10 centimeter. This means object distance is again given to us, that is P is equal to 10 centimeter. And next, spherical mirror and its virtual image is formed. So its virtual image is formed. Here the image is what? Virtual. At a distance of 5 centimeter from the mirror. So this means what is given to us? That is image distance is given to us in this numerical. We are supposed to find the focal length. Focal length means we are supposed to find F, and nature of the mirror. Nature of the mirror means we are supposed to tell which mirror is used. Means is it concave mirror or convex mirror? So let's do this numerical. Okay, so it's the problem set like 3.2. So given data, what is given to us is object distance, that is P is equal to 10 centimeter, and next we are given with is Q, image distance, that is 5 centimeter, and moreover we are supposed to find one more thing is given to us. So the image is what? Virtual image. Virtual, remember. So image is what? Virtual. So now we are supposed to find two things. Number first, we are supposed to find the F, and number second, nature of mirror. So mirror, what will be the mirror? Or we can simply say nature. What will be the nature of mirror? So we are supposed to find two things. So let's do with the first. So I'm doing like for F. So we will be using formula. So the formula is like 1 over F is equal to 1 over P plus 1 over Q. So after this step, what we have to do, you know better, putting the values. We have to put the values. So by inserting all the values, like P is given to us, that is 10, Q is given to us, that is 5. And after this step, what we have to do is we have to take LCM. So when we take LCM, what will happen? So you know better, 1 plus. So one more thing, it's very important. So because the image is virtual, remember here the image is virtual, so what you have to plug in is, like, you have to take Q minus. So that is very important, because you must know when the image will be virtual, so you have to take Q minus. So I am writing the Q minus over here. So afterwards what will happen? So this step is very important, so you have to do it like this way. Why I have taken Q minus? Because when the image will be virtual, so you have to know Q must be negative. That's very important. So after putting the value, like I am taking LCM, so what will happen? 1 minus 2 over 10. So it becomes 1 over f is equal to minus 1 over 10. So f is equal to, after cross multiplication, we got f is equal to minus 10 centimeter. Now we will be doing for nature. So for nature, let me explain you some rough work over here for you. So we have to remember this is rough work to understand the nature. So since we have two types of mirrors, one is concave and the other is convex. So remember, so the image of concave mirror will always be what? It will be real image. So you have to remember, the image of concave mirror will be real image, and the image formed by convex mirror will be virtual. So you have to remember these things. And moreover, Q will be plus for concave mirror or real image, and F will be also plus value. You have to remember this thing as well. When the mirror will be convex, Q will be negative, or when the image will be virtual, Q will be negative value as well. You have to remember. And when a mirror will be convex or image will be virtual, F will be also negative value. You have to remember this thing. So that's why we took this Q minus, because of this virtual image. Since the image is virtual, so what will be the nature of mirror? When the image is virtual, so the mirror will be convex. You must know from this very rough work. So the mirror will be what? So the mirror will be convex. So nature of mirror is convex. So this is the answer. So in this numerical, we were supposed to find two things. One was we were supposed to find F, and the other was nature. So since the nature of the mirror is convex, so we got the answer like this way. I hope this numerical is pretty clear to you. So for more numericals, stay tuned, stay updated. In the next videos, probably I will be explaining the remaining numericals of this chapter. Thank you.